Good morning, children. I hope you all received the marks which I have been sending you. Many of you have not done the test well. You've scored very less marks. I don't know the reason why, in spite of revising so much. I don't know why you have done like that. But I expect in the coming weeks you will do much better. So I thought of telling the corrections that the mistakes that you made in the other day's test. Okay. um, Mostly first, second, third question I had actually asked this question: where should an object be placed in front of a concave mirror so as to obtain inverted and diminished image, inverted and enlarged image? Now, the question was, so to get an inverted and diminished image, inverted and diminished, or you see the table, inverted diminished image, where should the object be kept? Beyond C. So your answer should be, for the first part, beyond C, and then you should have drawn the case 2 ray diagram for that, because in this only you're getting inverted and diminished. Now this also is diminished, but see, it is extremely small, or if you see in this table, it is highly diminished. So please don't draw this. If they ask you diminished and inverted, you please only do this second case. Don't do the first case. First case, highly diminished. Okay, so keep that in mind. And then the second part of the question was inverted and enlarged. Inverted and enlarged. Okay, and so it would have been the position of object should be between C and F. Your answer should be between C and F. And which diagram you should have drawn? You should have drawn the fourth case ray diagram. Case 4 ray diagram. Again, not this one, because this is extremely enlarged. So if it is just enlarged, you have to draw case 4. Okay, highly or extremely enlarged, then case 5. I hope you got an idea. Okay, so please make sure these ray diagrams can be asked. They can ask directly also, like draw the ray diagram for concave mirror when object is at C, object is at F. That way also. Or the other way is they can ask questions based on the size. Draw ray diagram for concave mirror when it forms a highly diminished image. So you should know that is case 1. An object should be at infinity. Okay, so draw ray diagram of concave mirror when it forms image of same size as object. So you should know, to get an image of same size of object should be at C. So I have to draw the case 3 ray diagram. Is it clear, children? So the questions can be asked based from position of object or size of image also, or position of image also sometimes. So you should be prepared and you can expect any type of question. Okay, so reasoning questions I had already told. So this one is the use and these are the reasons given. Okay, so that mostly you all are done correctly. And then principal focus of convex mirror. Again, most of you had done it wrong. The point on the principal axis where a beam of light traveling parallel to principal axis after reflection. Now till this, the definition is common for both principal focus of concave mirror and principal focus of convex mirror. Okay, if it is convex mirror, so what you will write? The point on the principal axis where the beam of light traveling parallel to principal axis after reflection appear to meet. Appear to meet. Okay, for concave you will write actually meet. For convex you will write appear to meet. So this part is common for both the things. This part will come. Okay, if it is asked principal focus of concave mirror, also you will write this first line, the point on the principal axis where a beam of light travels parallel to the principal axis after reflection actually meets. That is the principal focus of concave mirror. If I ask you principal focus of convex mirror, first line will be the same. point on the principal axis where a beam of light traveling parallel to principal axis after reflection appears to meet is called the principal focus. And for concave, you will draw this diagram, and for convex, you will draw this diagram. I hope you're clear with this. Okay, and please study thoroughly and clearly when you study the next time. For this week, we are going to revise chapter 4, energy. Chapter 4, energy. Okay, so today during your homework time, okay, I'm not giving any other work, so you will be studying page number 62, okay, 62, 63, 64, 65 and 66. Okay, till this you will study till this. Okay, and like last week, I'll be sending a assignment paper or a worksheet, you can call it, around 5 o'clock or 6 o'clock, and you can write the answers and send it to me. That's like a practice. Okay, I won't give you marks, but it's just for your practice. Okay, so if you are really sincere, you want to study, you want to score good marks, you can do this. If you don't want, you don't do, you will be the loser. Okay, I'm not going to say anything more. Now I'll tell you what all to study in this. First, you will study the definition of work. Yeah, these 2 lines. And then in this, from this examples or any other example also can come. They will give you examples and ask, is work done in this case? Okay, is he doing work? A man tries to push a wall but is unable to push. Is he doing work? So the thing is, only when a body moves, we say work is done. Though this man is applying force, the body is not moving, so no work is done. So these, please go through these ones. You might get questions or examples other than this also. So be prepared. Then you should study conditions for doing work. The question will be, what are the 2 conditions for work to be done? And then formula. Okay, what is the formula for work done? Force into displacement. You should know it in words also. Then you will have unit of work. So SI unit of work is joule, symbol is J. Then define 1 joule, the definition of 1 joule. And then what are the bigger units of work? Kilojoule, and 1 kilojoule is 1000 joule. Okay, then you will have the numericals based on this formula. Work done is force into displacement. So please practice these, go through these numericals, and then in the next page you will study energy definition. Energy defined as the capability of doing work. Then SI unit of energy is again joule. Bigger units kilojoule, megajoule, gigajoule. And then there are various forms of energy. What are they? Okay, till this you will study. Okay, rest half we will do it on Thursday. So study this portion thoroughly. Children, you all have been writing and writing, but you're not studying. Okay, so please please be serious. Take more efforts to study these thoroughly. Okay, study means you should be able to write without seeing. Other thing, on the other day, during the Zoom test, many of you have tried to copy, right? I don't know from where you had another phone and searched the internet, or you had your, I don't know where, I don't know how, but you all have copied. Not all, sorry. Some of you had copied, and I had mentioned it also. Okay, so don't do this. You're fooling yourself. Remember that. You're not fooling us, you're fooling yourself, and you will be the loser. Okay, so please please cooperate with the teachers, cooperate and learn the chapters. You will be really benefited. Okay, children, I hope this week, this chapter you will study thoroughly, and you'll be able to do well. Thank you so much.